Volcanicity, the ejection of solid, liquid or gaseous materials from deep-seated molten magma reservoirs beneath Earth's crust to the surface. Understanding volcanicity. Definition: rising of molten magma or gaseous materials from beneath to Earth's surface or within the crust. Process: all processes associated with ejection of magma and related materials from depths below onto Earth's crust. The volcanic process. Volcanicity forms when molten magma forces its way through weak points or vents in Earth's crust, escaping quickly or explosively to the surface. Magma formation. Mobile rock melts deep beneath the surface. Upward movement. Magma rises through areas of weakness from compression and tension. Surface eruption. Magma reaches surface as lava, cooling to form volcanic rock. Two paths of magma. Intrusive path. Magma cools and solidifies within Earth's crust before reaching the surface, forming plutonic rock and intrusive landforms. Extrusive path. Magma reaches Earth's surface, cools and solidifies as volcanic rock, creating extrusive landforms. Both processes create igneous rocks through volcanic or plutonic activities. Intrusive landforms. When magma solidifies beneath the surface. Dike. Vertical intrusion across bedding planes. Sill. Horizontal intrusion along bedding planes. Batholith. Huge granite mass forming upland regions. Laccolith. Dome-shaped upper surface with level base. Dikes. Vertical intrusions. Discordant formation. Rock, lying vertical or inclined across bedding planes, formed when magma solidifies within vertical faults. Physical features. Narrow wall-like features, rarely prominent in landscape. When exposed, may form shallow trenches. Examples: dikes in England, Ring Dyke in Joss, Cleveland Dyke of Yorkshire. Sills, horizontal intrusions. Unlike dikes, sills are sheets of solidified magma lying concordantly to sedimentary rock bedding. Formation process. Created when magma intrudes horizontally along bedding planes of sedimentary rock, forming concordant structures. Notable examples: Northumberland, England. Little and Great Karoo, South Africa. Batholiths, massive granite bodies. Huge masses of igneous rock, usually granite, that form massive and resistant upland regions after removal of overlying rock. Formation. Created by shrinking, melting, and incorporation of surrounding rock blocks into molten magma. Examples: Wicklow Mountains, Ireland, British uplands, French ranges, Malaysian main ranges. Specialized intrusive forms. Laccolith. Large igneous mass with dome-shaped upper surface and level base, fed by pipe-like conduit. Example: Henry Mountains, Utah, USA. Lopalith. Saucer-shaped igneous intrusion. Example: Bushveld Lopalith, Transvaal, South Africa. Thaccolith. Lens-shaped igneous mass in anticline crests or syncline bottoms. Example: London Hill, Shropshire, England. Volcanic necks and dike ridges. Volcanic necks result from solidification of lava in volcanic vents. Resist erosion better than volcanic cones themselves. Examples: Dumbarton Rock, Scotland. Devil's Tower, Wyoming, USA. Dike ridges. Steep-sided sharp ridges of volcanic origin, usually larger than volcanic rocks. Examples: Crazy Mountains, Montana, Great Dyke of Rhodesia. Extrusive landforms. When magma emerges at Earth's surface as lava. Vent eruption. Lava emerges through holes, building up volcanoes. Fissure eruption. Lava flows through cracks, creating lava plains or plateaus. Major extrusive landforms. Composite cone. Stratovolcanoes with alternating layers of lava, ash, and cinders. Lava dome. Steep-sided rounded mounds formed by viscous lava. Ash and cinder cone. Small volcanoes made mainly of ash and cinder. Caldera. Huge volcanic craters from violent eruptions. Composite cones. Stratovolcanoes. Grand mountain formations built of alternating layers through several eruption cycles. Structure. Alternating layers of lava flows, volcanic ashes, and cinders through multiple vents and parasitic cones. Eruption pattern. Begin with great explosions, an extremely viscous acid lava, containing dissolved gases, like water vapor and carbon compounds. Calderas. Volcanic craters. Huge craters often surrounded by shattered remains of volcanic cones, resulting from violent eruptions. Formation. Created when volcanic cones collapse after violent eruptions, forming craters several kilometers across. Lake formation. When water accumulates in calderas, crater lakes form. Examples: Lake Toba, Sumatra, Panyan Lake, Panction, near Jos. Basic lava cones, lava domes. Temperature and composition. Made of very hot lava, about 1000 degrees Celsius, in liquid form, allowing long-distance flow. Flow characteristics. Flow as thin, mobile sheets for great distances before solidifying due to high temperature. Example: Mauna Loa in the Pacific Ocean demonstrates this type of volcanic formation. Ash and cinder cones. Small volcanic cones composed mainly of ash and cinder, typically occurring in groups. Rarely exceed 300 meters in height. Examples: Volcán de Fuego, Guatemala. Icare Cone, Ekiti, Nigeria. Mount Vesuvius, Italy. Mountain Priscilla, Morocco. Hot springs, thermal features. Thermal springs that emit hot water quietly without violent eruption, rising from deep rocks to the surface. Mineral content. Often contain dissolved minerals with potential medicinal value for therapeutic purposes. Tourism and recreation. Provide major tourist attractions worldwide, offering relaxation and natural beauty. Notable examples: Ikogosi Hot Spring, Ekiti State, Nigeria. Thermal springs in Japan and Hawaii. Geysers, explosive water features. More violent than hot springs, geysers emit superheated steam spouting up to 46 meters high. Formation process. Water below is heated beyond boiling point, 100 degrees Celsius, in thermal volcanic regions. Jets emit with explosive force triggered by gases from heated rocks. Global locations: Iceland, North Island, New Zealand, Yellowstone National Park, USA. Practical applications. Energy generation. Geothermal springs harnessed for heating homes, swimming pools, and domestic purposes, especially in Iceland. Tourism and wellness. Hot springs and volcanic features attract millions of tourists worldwide, supporting local economies. Agricultural benefits. Volcanic soils are extremely fertile, supporting agriculture in volcanic regions globally. Volcanicity. Shaping Earth's landscape through the powerful forces of magma and lava. Intrusive forms. Dikes, sills, batholiths, and other underground features. Extrusive forms. Volcanoes, calderas, hot springs, and geysers. Global impact. Creating landscapes, fertile soils, and renewable energy sources.